This will be another video for our AUTOGLUON, and it's a new low-code ML tool which we'll be using in this session. And here, like, I'll demonstrate few of the videos like the AUTOGLUON Tabular in-depth and quick start, and the multimodal data tables and etc. And the AUTOGLUON Tabular future engineering, and as well as like I'll predicting multiple columns in a table in a multi-label predictions, and the training models of the GPU, like how to change the GPUs and other things. So I'll be explaining all these topics in this video. So for basics to basics, first we need to import the library, that is pip install AUTOGLUON Tabular. All specified means it will import everything, like from starting to ending, and just with the tabular it might vomit few of the things, so better to import with all the things. So according to it will adjust the things. And the next is to import the AUTOGLUON tabular and import the tabular dataset and the tabular predictor. So, and as well as I'm importing NumPy here and the sample dataset. This will result the sample subset of the data in a faster demo, as subset is 100 and the AUTOGLUON dataset is here, and the print is the function where we see occupation labels and other things. And this is for deleting the label column, and we specify evolve matrix just for a demo, but by default this will be the matrix for the accuracy one. And this is the output for that, like our data set and other things, and this is specifying the hyperparameters and tunings will be done here. So here is the NN options, the specified non-default hyperparameters value for neural net modules, and number of epochs, how many it has to be there, and learning rate used to be for trainings, and the activation is used in a NN again, I mean neural networks, and the dropout probably the real-time hyperparameters are this. And GPMU options, the specific non-default hyperparameter tunings and other things. It's all about the hyperparameter tuning and those adjustments like HPO and non-performed in a specified task. And this is the example for that, and how many time like it ran, like how many minutes it ran, and then number of trails and other things where we can see all the filtrations of part here. And once it's done, then we had to demonstrate how to the training models is predicted. So this is the prediction models assets, and these are the my columns out of it. And results is equal to fit summary. The fit is now command will show the hyperparameter tuning of the processing of each model here. And once it's done, the model ensembling with stacking or bagging. So here both will be possible, like the class and save path is the pg models where folders were stored in a train model sets and other things. And the next we go is to just a second. Next is tuning the data and auto stacking and other parts where f1 matrix will be measured. The last two arguments is the quick demo of how it will be performed and other things. So once here is the demo example, and decision tree calibration. Here is the decision tree calibration for this. And once the matrix in a score, then we need to do the test score setup, I mean. So either the training will be say 70/30 or 80/20, depending upon the model and the other things. And once it's done, that then reset decision threshold. Here that's by default it will take the prediction threshold as 0.5, and we can fine tune the decision threshold later if we don't get a proper f1 matrix and other things. And this is the predictions of option interface, like this it will be the prediction features. And the data point where ilog 0 is won't work because it returns the panda series instead of a data frame. And the prediction probables and data sets here that returns a data frame that should which probability corresponding with the class and other things. And the prediction leaderboard that test score, like which one has the highest accuracy of F1 and other things, like evaluating things, and the label predictions and other things. So these are about the predictions, like, and the different features available. So depending upon that, we have to use it, like the keeping models in memory, and here the acceleration interface and other things. So it's all about the deep dive of uh, tabular in depth, like what are all the features available, like collapsing bagging embezzle, AVR reference and other things. The model distillations is another major part here. This will be performed either with a distillation or a refit underscore full. So these two are the functions which produce additional models where we can opt to use for predictions and other features, like whether the paste will be good quality, high quality and other things, where how much prediction accuracy has to be there. So the highest quality will take a more time depending upon the data set and other things, like here k nearest number and ln torch will be executed as a model types and the fitting models. And once it's done, this is all about the in-depth tabular review and other things. So in the similar way, like I'll quickly go through the other parts as well, where here the tabular quick start is there, where the pip install AUTOGLUON, upgrade the pip and other things. These are the basic commands that we need for pip. And once it's done, then we need to take the data, the AUTOGLUON, import the tabular datasets and data predictions. And once we load the data, by default this is the head to display top 5 things, and the label will be signature label, or this might be target variable for us. And other thing here, the training, here with a single code we can feed the training data and we can train the entire model. And here the prediction section for us, and here is the predictor dot evaluate. These are direct steps, like with our data, like we can do it in few minutes kind of task. And the prediction leaderboard test score, this will display the highest accuracy for which model we are getting. And this is all about the quick start of tabular datasets. And once the tabular dataset is done, then we are moving to the other part, where multimodal data or tables will be loaded from the tabular text, image and other things. So here pip install AUTOGLUON, and once it's done, then the download the directory file and zip it the file. And then we import the AUTOGLUON load zip to unzip the zip package of the Kaggle from where we downloading it. And once the OS is done, then we need to import the OS and unzip the part, and the loading part of the data will be done here. And here is the training images for the data, and the pandas will be imported here. And here the train and dev.csv will be splitted, and the training data dot head, this is our data where we imported and other things. Like I'm looking, these are the description of our data sets and other columns for it. And once it's done, then label will be adoption speed, and images will be that. And preparing the image column, so here we create the, we prepare for the image columns and the training images. And once it's done, the training image dot head will show the, like how it's done. Then analyzing an example below, so this is the example of one specific sample of our data, and example dot description for the example. This is the image we got there. And the training data dot samples is this one. And constructing a future metadata. So here we import the future metadata from AUTOGLUON tabular, and we'll import this, and we'll pass that image path here. And then that will predict the features, like specifying the hyperparameter tuning, hyperparameters. Like here we have to import the configs for hyperparameters, and then get the hyperparameter config, either the multi-modular or single modular. So either we can fine tune the data sets and other things here, I mean models here. As again the fitting with the tabular predictor, like here the present will be high quality data, and we can decrease our priority based upon our time and efficiency. So once it's done, then the predictor or eval, that has data set, best will predict the data as in a test format, and the leaderboard will show the how much accuracy I got for this data one. And the next we go to the AUTOGLUON feature engineering. So here it's same process. Directly we need to import the pip function and AUTOGLUON importing part. And once the AUTOGLUON importation is part, then we need to import the numpy, panda, and randoms, skykittle, and date and time. This will be used in a future thing. And AUTOGLUON tabular. And once the data set is done, then we need to create a column and date time column and a categorical new column and a straight column. So these are the things to demonstrate how they are processed in a long scale. So let's see the how AUTOGLUON features will be the data. So this is our data set and the pipeline features and with no parameters in it. And we can see that the tabular predict.float, we need to combine the defix and the dry data frames, since the fix fit experts in a single data frame here. So here bgm will be the hyperparameter tuning and other things. So here the fit will be the df1 thing, data frames of pandas, where and the print the length of a dfx where it will be 5, and the dfx will be printed here, and the missing value in the heading will be displayed in here. And once it's done, then we need to reprocess it. So for the reprocessing, we use a generator to fit dot transform x equals to rdfs. And the customization of the feature engineering will be done here. So overridden by the default areas, where minimum number of cats equals to 10, where that can be changed to any number of parameters according to the task. And my pipeline dot fit dot transform is the another fitting transform. And this is about the tabular feature engineering part, where how to optimize our things and other things, where customization and other things, where like I have demonstrated a video about this. And next will be predicting multiple columns in a table, like multi-label predictions. So here pip install AUTOGLUON will be common for all things. So here multi tabular data set importation and other part. So here the multi-class predictions and the if and else, in a function where we define if else loop to key value label for um, tabular predictor or str part to tabular prediction for this data. And this will predict the multi predictions is only intended for predictions multiple labels in a columns, and this one will be mainly used for that. And they have here is the def function for the thing, and the predict function here is the fit and predict, and by default init one. And the here is the evaluate function for that, and save model function, and the load function, predictor models, and other things. So as a training one, once it's called, then in a training data set we give the data set csv file, and we give the samples set. And here is a head about video, and here which column of the prediction based upon the others will be saved here, save path, the eval matrix, and other things. So here time limit will be 5, how many seconds the training tabular for each of the sections. So here labels and other things will be the fitting model for the train and the time related, where these will be fitted here. Once the fitting is done, then the interface and evaluation will be done. So again the data set will be loaded, and unnecessary jergy, and we are not cheating here, unnecessary, just to demonstrate these files. We are doing it so just to show that. And once demonstration is done, here is to load the previously trained multi-label predictors from a file. And here is a prediction and here is evaluation for that. And here a prediction called laid about function and other things. So this is all about the tabular multi-label thing. And at the last, this is the one where gpu utilization and other things I'll quickly go through. So if you wanna use some advanced GPUs and other things, where we need to change from CPU to GPU, we can use this like as in hyperparameters. We can add this in a section, and like pip install AUTOGLUON. And once AUTOGLUON is done, then we need to use hyperparameters multi-model, and here hyperparameters will be changed according to the GPU set. So this is all about the thing. like just with this one thing, multi-modular, it can import the GPUs and it can run. So even with this GPU, we can use a CUDA as well as a GPU, which will be faster. So in comparison with this, yeah, thank you.